Hey guys, welcome to my video on special products. So special products just continues our knowledge of multiplying polynomials and hopefully can find you some easier, faster methods of finding the products of these polynomials. But as a disclaimer, you can always use the FOIL method with any of these. So if you prefer using FOIL, use FOIL, but this is supposed to be kind of a shortcut, or if nothing else, just noticing a pattern that we can find in math. So our first example of a special product is the square of a sum. And the square of a sum is basically saying if we have any polynomial multiplication where we have an a plus a b and we're squaring it, we can simplify that to a squared plus 2 times a times b plus b squared. Now there is an example over here, but I wanted to show you a live example that also uses the same color coding technique that your book uses. So the first thing I'm going to do is I'm going to square my a term, which happens to be in red here. And if we square our a term, we've got 2x squared times 2x squared. And using your exponent rules, that becomes 4x to the fourth. So I'm going to write 4x to the fourth as the first part of my answer, and now it's used by squaring my a terms. The second part of solving this is a little bit trickier, and that involves 2 times a times b. So 2 times a in this case is 2x squared times b, which in this case is 3. It doesn't matter which order you want to simplify it in. I'm just going to call this 4x squared times 3, and either way that gets us to 12x squared. So 12x squared is the next part of solving this. Now it's done by doing 2 times your a term times your b term. And finally, last part is squaring our b term. And I don't think we really have to do the math out for this. 3 squared is 9. So we're going to do plus 9. And I got that by squaring my blue b term. Now, the best policy is always to make sure before you leave that problem that there are no ways to simplify it. And sure enough, there are no ways to simplify this. We've got a 4x to the fourth, we've got a 12x squared, and we've got that 9 that technically has a degree of 0. So no like terms here. We're good to go to our next problem. The second example is the square of a difference, and basically very similar to squaring a sum, but instead, if we have a subtraction sign in the middle, we do it just a smidge differently. We've got a squared minus 2ab plus b squared. So very similar. I'm going to start off by doing my a squared, which 3x times 3x gives us 9x squared using those exponent rules. And I'm going to put that in red because I got that from squaring my a term. Now, the trickiest part of the square of a difference is knowing that when it comes to these b terms, we're not going to think of them as negative ones. They're actually just thought of as the b term itself, or that constant itself, which in this case is 1. So we're going to do minus 2 times our a term, which is 3x, times our b term, which is 1. Now, 2 times 3x gives us a 6x. 6x times 1 gives us 6x. We can get rid of the parentheses, and that leaves us with 9x squared minus 6x. And once again, I know that your gut is telling you that b is a negative 1, but in this case, using these square differences, we actually think of them as just the number itself, which in this case is 1. And finally, we've got our b squareds. 1 times 1 is 1. So our final answer is going to be 9x squared minus 6x plus 1. And once again, no like terms here. We've got a squared term, a term with a degree of 1, and our constant that has a degree of 0. So no like terms here. Whoopsies. Forgot to put that out of there. Your final answer is 9x squared minus 6x plus 1. Finally, we've got the product of a sum and a difference. This is an even more specific case. where you have two a terms that are the same, two b terms that are the same, but one's being added and one's being subtracted. And in this case, it's possibly the easiest one to have memorized. You're going to square your a term, you're going to subtract your b term that's being squared. So in this case, we've got our a term of 3x. As we've established, 3x squared is 9x to the second. And that's because we squared our a term. So I'm going to put that in red. Minus is in between. And then our b term is the numeral 2. So 2 squared gives us 4. Pretty simple. Looking at our final answer, there are no like terms here, so our final answer is 9x squared minus 4. Now again, you can always use FOIL, there's nothing wrong with FOIL, but it is slightly easier for things like product of a sum and a difference to just kind of do it this way, so really about your comfortability personally. So as a recap, if we square a sum, we do a squared plus 2ab plus b squared. Square of a difference, we do a squared minus 2ab plus b squared. And remember, you treat the 1 in this case as a positive 1, not a negative 1. And similarly, we've got a squared minus b squared, where you're still going to treat both of these 2's in this case like they're positive. If you have any questions, let me know. I do have an assignment for you that's going to be basically a quick Google form review of what we've learned so far with polynomials. My suggestion is to try to do it on paper before you fill out that form, because I'm not sure if you'll be able to finish it during class time. So start your work on paper. When you finish, enter it into the form. Have an awesome rest of your day, guys, and I will see you tomorrow.